So why did we do factoring? As I mentioned earlier, in math, we want factors, writing things in factors, writing expressions in factors have a lot of applications. One of the most important application is to find solutions to an equation. Here we're just going to look at polynomial equations of degree 2, which often result in binomials or trinomials. So, going to start with something simple. I have a polynomial that is already factored on the left-hand side, and notice the right-hand side is 0. Now, if that is the case, then I could solve directly. A most common mistake that people tend to do is to apply factoring, finding the solution directly for factors when the right-hand side is not 0. The right-hand side has to be 0. So how do we solve? Well, if x plus 2 times x minus 4 is equal to 0, then either x plus 2 is 0, or x minus 4 is 0, or both of them are 0. So if I set x plus 2 equals 0, x is equal to minus 2. If I set x minus 4 equals 0, x is equal to 4. So the solution, or the solutions are x is equal to minus 2 and x is equal to 4. Why do we call them the solutions? If I took these x values and put it back in the equation, that equation will be satisfied. If I put negative 2, I'll have negative 2 plus 2, negative 2 minus 4 equals 0. Negative 2 plus 2 is 0. Negative 2 minus 4 is negative 6. 0 times negative 6 is 0. We get 0 equals 0, which is true. So it works. At x is equal to 4, I would have 4 plus 2, and 4 minus 4 equals 0. 4 plus 2 is 6. 4 minus 4 is 0. 0 equals 0. It works. So the solutions are negative 2 and positive 4. Those are the only two numbers that would satisfy the given factoring or the given trinomial in factored form on the left-hand side. The previous problem was easy in the sense they gave us the factored form. All we had to do is to set each factor equal to 0 and solve for x. Here, we don't have the factored form, but we want to solve for x. So the first step to do would be to factor. That would be step 1. And we know how to factor this. The last number is 12. I can write 12 as 4 times 3, or 6 times 2, or 12 times 1. Of the 3, that is not going to work. That will not work, but that is going to work. because 6 plus 2 is 8. So x squared plus 6 plus 2 times x plus 12. X squared plus 6x plus 2x plus 12. If I pull x out of the first two terms, I would have x plus 6. If I pull 2 out of the last two terms, I would have x plus 6. X plus 6 is in common. If I pull that out, I will have x plus 6 times x plus 2. Now the second step is to solve. X plus 6 times x plus 2 equals 0 because I just factored that and I wrote it this way. So they are equivalent expressions. So solving for the given equation is the same as solving for the factored form of the given equation. So since we have two factors, we set them equal to 0. If x plus 6 is equal to 0, x is equal to negative 6. If x plus 2 is equal to 0, x is equal to negative 2. And those would be the solutions. So the very first step is to factor. So if I look at 12x squared plus 5x minus 2, I have negative 24, which would be the product of those two. So that would mean I could write that as 6 times negative 4, negative 6 times positive 4, 5 times, 8 times negative 3, negative 8 times positive 3, 12 times negative 2, negative 12 times positive 2. All of those are possibilities. If I add 6 and negative 4, I'm not going to get 5. If I subtract, I'm not going to get 5. Same applies for the other one. If I add 8 and negative 3, I'm going to get 5. So once that happens, you really don't have to check the rest. You have the golden egg. So I am going to write 12x squared, split that 5 as 8 minus 3x minus 2. 12x squared plus 8x minus 3x minus 2. I have 4x in common. If I pull 4x out of 12x squared, I'll have 3x. If I pull 4x out of 8x, I have 2. If I pull negative 1, I would have 3x plus 2. Now I have 3x plus 2 in common. If I pull that out, I have 3x plus 2 multiplied by 4x minus 1. So I have the factored form, so I could rewrite the given expression as 3x plus 2 times 4x minus 1 equals 0. This would mean I can set each factor equal to 0 and solve for x. So 3x plus 2 equals 0 would imply 3x is equal to minus 2. X would be equal to negative 2 over 3. 4x minus 1 equal to 0 would mean 4x is equal to 1. X is equal to 1 over 4. So x squared plus 6x plus 9. Of course, you could use the traditional factoring approach. The way I look at it is that anytime I see a perfect square, over here, or when I multiply that number 9 or whatever the number is and multiply with whatever number I would have there, if I end up getting a perfect square, excuse me, I take that back. If I have a perfect square, the last term, and if this happens to be a perfect square also, in this case it is, I would always like to or go for a special product. So I see a plus sign. So the special product that I must use would be a squared plus 2ab plus b squared. This would imply a squared equals x squared. Therefore, a is equal to x. B squared is equal to 9. Therefore, b is equal to 3. So I could factor the given equation as a plus b times a plus b. So x plus 3 times x plus 3 equals 0. You set each factor equal to 0, you are going to end up getting the same solution. This is what we call a repeating solution. But it's just minus 3,3 because both solutions end up being negative 3. So, as I mentioned in the previous problem, I go for a special product if I could see perfect squares. That's not a perfect square. 2 is not a perfect square. So a special product is not going to help me here. So I'm going to go for grouping. So 6 times negative 2 is negative 12. I could write that as 4 times negative 3, 3 times negative 4. 4 times negative 3 gives me x, so right away I can pick that and ignore the other one. So I could write 6x squared plus x minus 2 as 6x squared plus 4x. 4 plus 3, minus 3x minus 2, which would give me 6x squared plus 4x minus 3x minus 2. I have a 2x in common in the first two terms. If I pull that out, I would have 3x plus 2. I have a negative 1 in common. If I pull that out, I would have 3x plus 2. So I have a common factor. If I pull that out, I'll be left with 2x minus 1. So the two factors are 3x plus 2 and 2x minus 1. Which would mean the given expression can be written as 3x plus 2 times 2x minus 1 equals 0. Set each factor equal to 0. (3x plus 2 equals 0) would mean 3x is equal to -2. X would be equal to -2/3. 2x minus 1 equal to 0 would mean 2x is equal to 1, and x is equal to 1/2. So those would be the solutions to the given equation. This is a problem that is meant to reinforce something that I mentioned earlier. The right-hand side must always be equal to 0. That is not the case here, but we can make it 0. So x squared minus 6x equals, distribute the x, you will have 8x plus x squared. Move everything to one side. So x squared minus 8x minus 6x minus x squared would be equal to 0. The x squareds will go away. We will have negative 14x equal to 0, which would imply x is equal to 0. So I'll demonstrate one of the most common mistakes that students make. We look at this equation and come to an immediate conclusion because of practice that x is equal to 3 and 5x plus 2 is also equal to 3. So x equals 3 would become one solution. 5x would be equal to 3 minus 2. 5x would be equal to 1. X would be equal to 1/5. Now, this happens because anytime we have factors, we set each factor equal to 0 and we solve. In this case, instead of 0, we have 3. So we are setting each factor equal to 3. This is absolutely incorrect. The right-hand side must always be 0. Nothing else would work. It has to be 0. So our first step must be to make sure that we have the right-hand side as 0. So we have x times 5x plus 2 equals 3. Distribute the x, 5x squared plus 2x would be equal to 3. 5x squared plus 2x minus 3 would equal 0. So we have a trinomial now, and the right-hand side is 0, and we want to factor it. 5x squared plus 2x minus 3 equals 0. We have 5 times -3 from this number and that number, which would give us -15, which we can write it as 5 times -3, -3 times 5, 15 times 1, or -1. Those are the only possibilities. And 5 minus 3 is 2. That works, so the other two doesn't matter. So 5x squared plus 5 minus 3x minus 3 equals 5x squared plus 5x minus 3x minus 3 we have a 5x in common between the first two terms. If I pull that out, I would get x plus 1. I have a negative 3 in common. In the last two terms, if I pull that out, I would have an x plus 1 in common. And now x plus 1 is in common. And we can pull that out, which would give us 5x minus 3. Set each factor equal to 0, and we solve for that equation. So 5x squared plus 2x minus 3 equals 0 is the same as saying x plus 1 times 5x minus 3 equal to 0. If we set each factor equal to 0, x plus 1 would equal to 0, 5x minus 3 would equal to 0, x is negative 1, 5x would equal to 3, divide by 5 on both sides, x would be equal to 3 over 5. And that is the final solution. We have fractions, and in a problem like this, people might think converting the fractions to decimals would be a great idea, but unfortunately, it is not. You are actually making things way too complicated. So what should we do in a problem like this? We have to try and eliminate the fraction. We look at the denominators and pick the greatest one, greatest denominator, which in this case is 20. And multiply both sides by 20. Twenty times x squared over 2 plus x over 20. Distribute the 20. You have 20 times x squared over 2 plus 20 times x over 20. 20 over 10. 2 and 10 would get cancelled. 20 and 20 would get cancelled. 10 and 2 would get cancelled, which would give us 10x squared plus x equals 2. Mind you, the right-hand side is not 0, so we've got to move that from the right-hand side to the left to make sure that the right-hand side is 0. So 10x squared plus x minus 2 equals 0. Now I look at the last and the first coefficient, and I would want to come up with two numbers so that I get the middle number right next to x as 1. Well, 10 times negative 2 is negative 20. 5 times negative 4 is negative 20. Negative 4 times 5 is negative 20. If I do 5 minus 4, I'll get 1, so that's going to work. I can get rid of the other. So I could write 10x squared plus x minus 2 as 10x squared plus 5 minus 4x minus 2, which should be 10x squared plus 5x minus 4x minus 2. 10x. I have a 5x in common in the first two terms. If I pull that out, I have 2x plus 1. I have a negative 2 in common in the last two terms. If I pull that out, I would have 2x plus 1. Now I have 2x plus 1 in common. If I pull that out, I will be left with 5x minus 2. So the factored version of 10x squared plus x minus 2 is 2x plus 1 times 5x minus 2. So I could set the factored version equal to 0. Because 10x squared plus x minus 2 is the same as 2x plus 1 times 5x minus 2. So this would mean 2x plus 1 equal to 0, 5x minus 2 equal to 0. 2x would be equal to negative 1, divide by 2 on both sides, x is negative 1/2. 5x would be equal to 2, divide by 5 on both sides, x would be equal to 2 over 5. And those are the two solutions. So the process is ultimately the same, but the idea is to rewrite the given expression in a simpler form by eliminating the fractions. So here we have y squared over 30 equals y over 15 plus 1/2. We have fractions. We want to eliminate the fraction first. The biggest of the three denominators is 30. So I'm going to multiply both sides by 30. So 30 times y squared over 30 would be equal to 30 times y over 15 plus 1/2. 30s would go away. Y squared would be equal to 30y over 15 plus 30 over 2. 15 and 30 would get cancelled. 2 and 30 would get cancelled. So y squared would equal to 2y plus 15. We want to move all the terms to one side, so y squared minus 2y minus 15 equals 0. So the right-hand side becomes 0. Now we want to factor negative 15 times 1. Negative 15, 5 times negative 3 would give us negative 15. Negative 5 times 3 would give us negative 15. If I add 5 and negative 3, I'm not going to get negative 2, so that won't work. If I add negative 5 and 3, I will get negative 2, so that would work. So y squared minus 2y minus 15 would equal to y squared plus 5, negative 5 plus 3 times y minus 15, y squared minus 5y plus 3y minus 15. We have a y in common in the first two terms. So if I pull that out, I would have y times y minus 5. We have a 3 in common in the last two terms. If I pull that out, I would have y minus 5. Y minus 5 is now in common. If I pull that out, I would leave behind y and 3. So the factored version is y minus 5 times y plus 3. And we are going to set it equal to 0 to solve. Set each factor equal to 0. which would mean y is equal to 5 and y is equal to -3. So we have 3 factors on the left-hand side and the right-hand side is 0. So this simply means I could set each factor equal to 0. And solve for x, which would mean x is equal to 6, x is equal to 1, and x is equal to 2. You have 3 solutions. Keep in mind, if you have 2 factors, you get 2 solutions. If you have 3 factors, you get 3 solutions, and so forth. Here we have x cubed minus x equals 2x squared minus 2. I am going to move all the terms to one side, so the right-hand side is 0. In the first 2 terms, I see an x in common. So if I pull that out, I would have x squared minus 1. In the last 2 terms, I have a -2 in common. If I pull that out, I would have x squared minus 1. Now I have x squared minus 1 as a common factor. If I pull that out, I would have x squared minus 1 times x minus 2. We have to set each factor equal to 0 and solve for x. So x squared minus 1 equals 0. X minus 2 equals 0. X squared minus 1, if you notice, this is of the form a squared minus b squared. This is why we learn special products. Since it is a squared minus b squared, a squared is x squared, which would mean a is x. B squared is 1, which would mean b is 1. We know we could write a squared minus b squared as a plus b times a minus b. So from the first one of the factors, which is x minus 2, I get x is equal to positive 2. Now I have 2 factors, x plus 1 and x minus 1. I set each of them equal to 0, x plus 1 equals 0, x minus 1 equals 0, which would mean x is equal to 1, or x is equal to -1. The other solution is x is equal to 2. So the 3 solutions are 1, -1, and 2. As I mentioned earlier, if you have 3 factors, you will have 3 solutions. If you have 2 factors, you will have 2 solutions. They could be repeating solutions. We've seen that in one of the problems. If you have 4 factors, you will have 4 solutions, and so on. We'll start with the most common mistake in this problem. Oftentimes, this is what people would do. Look at x cubed here on the left-hand side, x on the right-hand side, and go ahead and cancel that x and write it as x squared minus 4. This is great and all. Oops, sorry. X squared is equal to 4. And you have to make the right-hand side 0. So you'd move that 4 to the left-hand side. So you have x squared minus 4, which is of the form a squared minus b squared, which I can write it as x plus 2 times x minus 2. And you would conclude the solutions are 2 and -2. This is okay, but the people who take this approach forget that there is another solution. So the correct way to do this is to move (4x) to the left-hand side. And we have an x in common. If we pull that out, we have x times x squared minus 4 equals 0. Now I could write x squared minus 4 as x plus 2 times x minus 2 equals 0. We already know that using x plus 2 times x minus 2 equals 0 gave us 2 solutions. So we have accounted for that. And there is one other factor, which is x equals 0. So the solutions are x is equal to -2, 0, and 2. So it is imperative to note that you don't cancel the x's. If you cancel the x's, you actually forget, or you will end up losing one of the solutions. So the better approach is the one on the right.